Welcome everybody to the RISA webinar, Designing Built-Up Sections with RISASection and RISA-3D. My name is Deborah Brisbane. I will be presenting today, and we'll be talking about two of the programs here in RISA-3D and RISASection. RISA software has many programs that integrate, but today in particular, RISASection is version 2.0 is what we're going to be focusing on. 2.0 is about to be released. We should be getting that soon. So what everybody currently has, if you own RISASection, will be version 1.1. So this is a full upgrade, and we've added a lot of new features in here, and we'll be kind of seeing some of how to use RISASection, but we'll also be talking about the new features we're going to see in 2.0. RISA-3D 9.1.1 was released to be able to integrate directly with RISASection. So it's a minor release that came out last week, but what you'll see there is that it has the ability to integrate right in RISASection, as well as RISA Connection was added for integration. So a lot of the RISA software does integrate, and you'll see that, but and today we'll just talk about these two. Let's talk about RISASection a little bit further and some of the features that you'll find in RISASection. The first thing is it's a section properties calculator. So it's going to be automatically calculating the section properties of your section that you place into it. You can do multiple shapes. You can do just single shapes. And automatically, upon any change that you do, the calculations are done behind the scenes and refreshed for you. So that's kind of the main reason we're using RISASection, obviously. But some of the other things is it's a full graphical interface. So unlike RISA-3D, RISA-2D, those programs started out years ago where they were spreadsheet-based and they sort of built on a more and more graphical interface. RISASection is a little newer, and you'll see it's sort of originated there as a graphical tool. So we're going to see how easy it is to snap things together and modify our models and work with that all graphically. It also allows us to combine multiple materials. So just like we see in other RISA products, you can combine different shapes or different materials together. So you can do concrete, hot-rolled steel, cold-formed steel, and general. You can add those all into the same model. When I say general, I'm mentioning things like aluminum or stainless steel, sort of outside of what we currently have in RISASection, but we can call those general. And we can put all of those shapes together. And we'll see that coming up. The other thing we've got here is metric and empirical units. So you can use different units there. It's going to be model-based, and it will be able to draw those in based on the units that you need. You can import your section directly into the other software. So as I was mentioning that you can integrate right into RISA-3D, you can also get your section property right into RISA-Floor or RISA-2D. And we're going to see how that process works a little bit farther. So as I said earlier, that RISASection 2.0 is coming out here real soon. And so what we're going to see is what some of the new things that happen in RISASection 2.0. And the big thing is that we get an integration into RISA-3D, but not only do we get our integration, we're also going to get code check for hot-rolled steel. So that's a big bonus. You're going to be able to actually take your section and get the code information directly out of RISA-3D. In the past, what you would have seen would be forces and the stresses in the model, but you wouldn't have actually been able to compare it to a code. So we'll see how we can do that. The other thing is importing DXF sections. So we can build any type of section property, any shape, any geometry in RISASection. But one of the nice things to do is if you already have it drawn in your AutoCAD or in any of your drafting software, you can save it as a DXF section there and just import it directly into RISASection. So we'll see we'll go through the process of how that works, and we'll see some of the ways you want to do that. The other thing is we improve some of the graphical tools. So you'll see we have a tool called a parallel align tool. It's a great way to snap things together, and I think you'll see how that becomes really helpful when we're doing composite shapes. One of the things I want to talk about, we're going to talk a little bit about the section properties and how they're calculated, but we're not going to go into the specific details of the actual calculations, but I do want to make reference to the book that we use here, and the reference is called The Stress and Strain in Structural Matrices by Walter D. Pilkey, and it's put out by John Wiley & Sons. If you want to see a little bit farther about how these things are calculated, I would suggest pulling this off your library or possibly purchasing purchasing it and going through some of the calculations on how do we actually make the geometric properties, including the area and the different moment of inertias and section properties, as well as the torsional and warping properties. We'll hit that a little bit, but we won't go into the specifics. So one of the things I want to do is jump right into the program. So I'm going to open up RISASection. You should all be seeing RISASection on my screen. This is, we'll talk a little bit about the interface in RISASection. So starting out, it looks similar to a lot of our programs. You're going to see some icons along the top. We're going to see some dialogues like Windows dialogues where they have drop-down boxes, and we're going to see sort of a menu here on the left and the right here. And one of the things that we've got, we're going to start, we have kind of basic concrete shapes, basic steel shapes, and we have some hot-rolled database shapes. And the last thing here is sections in current file. So to start off, what we work in here, when we take this into RISA-3D, the most important piece is what we call the section. The section title right here is called Section 1 right now. And actually it's a little confusing because we can see here the actual name of the project is called Section Project 1. So when we bring this into RISA-3D, what's important is that we're bringing in the section name listed right here. And I can add to these so I can have more than one section in a file. So we'll start by adding one in here, and then we'll see how we can add additional. The first thing we can do is let's add a concrete shape. So I'm going to jump back to basic concrete shapes, and I see a whole long list of basic shapes that I can add into my model. And I can see that there's very different types of shapes, so we can do something like an odd eye shape, general shape here. And as soon as I put it into the model, it goes right into my model space here. I get a three-dimensional view, or this looks like a flat view of it. But what I see is I can actually rotate it in 3 dimensions and see it a little bit better. But when I want to sort of modify this, it's just a general shape. I don't really see much about it. I can double-click on that shape there, and I can start to modify it. So I can maybe tailor this to what I need. Maybe I know that this side is going to be 4 inches and maybe 4 inches on this side, and I'm going to change this to be 2 inches. Just push refresh, and I'm going to see how this starts to work into a different shape. So I can do a number of different things over here to make this shape tailored to what I need. Maybe it's not 20 inches. Let's say it's going to be more like 24. And I just say refresh, and I'll start to say OK. And all of a sudden you'll notice that the right side of my screen, which is all the section properties, got recalculated based on that. So I have all the different shapes automatically happening based on every change I make. So I'm going to double click on this again, and I can, maybe I change my mind. Maybe this wasn't the shape I intended. You'll see that I have a whole list of different shapes, just like I do on the left side of the screen, on the top portion of my screen. So this time let's take a look at maybe a rectangular portion with an opening in it, in the circular opening. And right now I'm going to try to do is maybe make a composite shape, maybe with a steel I-beam and a slab portion on top of it in concrete. So maybe my slab portion is about 12 inches. And I can tell that maybe the hole is obviously not going to be as big. Maybe it's going to be maybe a 3-inch diameter hole in there, and it's maybe 2 inches off the bottom. And I can say refresh, and that goes to be the shape I need. And I can say OK, and I start to see that this is changing shape for me automatically. I can always also, not just double-clicking on there, I can actually drag it down a little bit so it starts to form a little bit better. I'm not as precise, and I can turn the units on a little bit, but what I want to do probably is change this a little bit more precisely with these numbers here. So we'll change this back to a 6 inches, and maybe we'll change this over here to 2 inches, and we'll go back to maybe 2 inches here. And the 20 inches, maybe we'll change that over to be like 12 inches. Okay, so we've got sort of an opening and a hole, and we have a rectangular piece there. And the next piece I'm going to do is this is our concrete shape. So what I can do is also add some basic steel shapes to this model. So we're making more of a composite section. So I'm going to go into the basic steel shapes and open up maybe the wide flange. Again, this is just a basic shape, so when I put it in, it has sort of some default settings of what the shape is. It's just a very large shape. So I can double click on this shape and change its properties too. I'm going to maybe it's a 10-inch depth and maybe let's say 6-inch width. And let's give it maybe 0.75 here. and just say refresh, and I can see, so its flanges are a little bit large there, and let's give it a 0.75. So I'm just sort of off the cuff going with something I need, and you're going to see matching flanges on the top and the bottom for this shape, and I can say okay. So now I have two shapes, and one's a concrete and one's a steel wide flange, but I do need to orient them properly. So what I can do is use some of my orientation tools. I can always drag it around. Again, that's a nice way to sort of get it into the right position slightly, but it's not going to be as precise as if I use my tools. So what I can do is sort of drag this around the area I want it, and I'm going to highlight both sections together. And the top tools here I have available shows me some of the things I can do. I can rotate this. I can rotate it, a group of them based on an angle. Let's just push that and see how that goes. So I can change this, rotate this whole thing by 45 degrees. Sort of an odd way for this model to go, but it's possible. The other thing that's really nice in RISASection is if I make a mistake, just push the undo button. So you don't feel scared to do anything in here. You can always click undo, and it will unlimited undos back to where you started. Okay, so and redo again, so you can actually push both buttons. So it's great to explore the different possibilities with the buttons because you won't be hurting your model there. So what I'm going to do is kind of highlight both of these back again, and I'm going to use some other tools I have. The ones I have here, I can align it to the left, for example, and we'll scoot that to the left, maybe align to the right. This one most typically would be aligned to the center. Okay, I have my opening right above there, and what I can do, so maybe my pipe is running down there. It's probably an odd place to put my pipe, but that's okay. The other thing I can do is I can use some tools here. So we did align to the left, align to the right. I can align them vertically so that they go all the way to the top or all the way to the bottom. Again, that's a little strange considering what we're looking at here, but if I highlight these two here, I can see that I can just align vertically, and that might be exactly what I'm looking for. This align vertically tool is kind of a great one for when you're doing these where so it'll line up together. Not quite in the right spot, but I can push the flip vertical button right here and get it oriented properly. So I could have done these things by clicking. I can orient one selection at a time or the two of them together. So once I have that in place and I have it all laid out the way I want to, I don't know if you have noticed, but on the right side, all of this has been changing based on what I've been doing in the model space. So as I look to the right here, I see that I have a finished product. I can see that there's some information here. So it gives me the total width, the total height, the centroid. I can see X bar and I can see Y bar listed here for the distance from the centroids. I've got some maximum thickness listed there. I've got some area. There's a little checkbox. We'll come back to how to alter this stuff in a second, but I just want to see some of the things that are available. So the moment of inertia is listed here. I've got the polar moment of inertia. I've got all the different elastic section and modulus. I've got some of my radius of gyration. And I can see I've got all the different pieces that are going into this. If you're familiar with RISA-3D, you can see some of these AISC def, which is really a shear deformation factor, a modifier that goes in front of that. And this is going to be the AISC stress. So that one is actually a shear stress factor modifier. And these things will get adjusted here when you go into RISA-3D. If you leave these blank, they won't modify those factors there. So we can see we can leave them at 1.0 right now. So this is my general section. So this right now is going to be listed as a general type section, and we can do lots of stuff, even not just, so let me retitle this because this one is my general composite shape. So it's important that you name your title. When I said here this is the section that we're using and the name was really important, it's kind of nice to be able to know what you're talking about. So what I'm going to do is say rename this section, and I'm going to call this composite section. And I'm going to say OK. And now I know kind of what this is, as opposed to what the title of the project is kind of a mass project. And what I suggest is probably maybe per project or per job, you build up some sections that you need and put them all in the same section file. So now to add another section file, I can add in a new section file by either right-clicking Add New Section, or I can see up here there's an icon that allows me to add a new section. And I click on that, and a brand new section comes in. And it retitles it Section 2. So maybe this time I'm going to do just a steel one. So I'll just call this Steel Test. and say OK. And so I can now have a steel test model, and I'm going to jump into the steel shapes. And I can see in here, I've got, once I go to steel shapes, I have wide flange, I have eye sections, channels, if I want to use some arcs, some solid bars or pipes. I've got pretty much everything I can possibly do. And if I needed something that is not on this, I can actually compositely put them together. So I could make like a solid rectangle shape, and then I could start to kind of tweak it into its own little shape. So I can put this together. Maybe I can add another solid rectangular shape. And let's see, if I start to make this one here, we can kind of shorten these up here. And double-clicking on them, you can kind of make them maybe a 1/2 inch thickness on this guy. And this one will be, let's say, a 0.6. Oh, I got an extra decimal in there. Say OK. And then I can maybe this is like a sort of a bent angle of some sort. And I can do is I can push this all the way over to, let's put them together and align them horizontally. So I'm going to select them both. And then I can align them together to the side here. So I'm going to say align them horizontally. That didn't quite get me where I wanted. So now I kind of want to show you this tool I have where it allows me to sort of align things using my parallel align tool. This is a brand new tool I mentioned earlier, but what it allows me to do is kind of select something, and I'm going to click on the parallel align, and then I can pick an edge, and it's asking me to pick an edge to align it to. So I want the edge of this horizontal section to line up with the edge of this vertical section. So if you see, if I hover over, it turns blue. I can say, let's click on that, and I'm going to click it all the way to this section, the inside actually. And so I see it moved it based on that. Let's try that one more time in case you missed that. What we can do is we can highlight this whole section. I'm going to highlight them both. Actually, I'm going to highlight one of them, and I'm going to parallel align them to the top of the section. So if I click on that, I choose maybe this edge, this outside edge here, and then the second click, it's going to say, where do you want me to parallelly align that to? I'm going to parallel align it up to here, and then I see that it goes up higher. So this is a great tool to help align my sections together. So then maybe I want to do is just maybe put this one on an angle. So I can just select just this section here and put it on an angle of 45 degrees. I can say OK, and then it scooted it a little bit, but let's put it back down here, and we can align that. Actually, it's pretty aligned right now, but we can align that to the bottom section here. So they're pushed down. You see it moves, scooted just slightly, and now I have sort of a bent angle. So something a little bit off the cuff than what I have in here. You can do additionally, you can choose cold-form shapes that are already in stat here. We have C-sections and lip C-sections and all sorts of stuff. I've got built-up sections. And we can see all sorts of things like that in here too. I'm going to jump really quick and show you some of the options. So if I go up to the options here, general options, we can see some of the stuff that's kind of defaulted into our model. Right now I'm working off of inches. So whenever I'm modifying my properties on my dimensions, I'm using inches versus feet or versus millimeters if I wanted to choose that. So I can adjust all the units here if I want to say it's the default setting. So if inches are not my default here, I can change that once I set that. RISA database here. So this is going to be where I'm going to be picking my database shapes, and that's where into my CRISA folder. There's a merge tolerance, so when I snap things together, there's going to be a little bit of a merge tolerance there. And it allows me to do, right now is 0.012 inches, and I can adjust that. Let's go over to view. If you wanted to change the colors here, in the right side of my screen, you'll notice I have like this bluish color for my hot rolled sections. And when we were in that concrete, it was that pink color. You can actually change that coloring there if you need to find a different color there. And for all the different shapes, the border and the filling. We can also look at the section properties. So right here, we have a base modulus of elasticity, and it's based on what the steel here is, 29,000 KSI. And that base modulus there allows us to specify. We have a property multiplier, and I'll show you that in a second where you can change that. And that helps you specify the relative weight of the shape's modulus of elasticity in the overall section. And we can see here we have the concrete right now modulus of elasticity, and we have the steel shape's modulus of elasticity. So we're using assuming that as this is the base, so we're assuming the base is going to be the steel shape. If I say OK, and I jump over to my current shapes and look at my composite section, if I double-click on any of this shape here, I see I have a property multiplier, and that little multiplier is going to help us specify the relative weight in calculating that modulus of elasticity. If I want the program to ignore that there, you can see in that section properties it says don't consider the modulus of elasticity for defining that there. So we can check that box if we wanted to ignore that. So I'm going to push cancel here. I'm going to go back to my steel test here. So we talked about basic concrete. We looked at some of the basic steel shapes, and we have some built up as well we said that there. One of the other pieces we have is the RISA hot rolled database. So when we were looking at basic, it was kind of off the cuff. It was making us modify everything in the steel shapes there and the concrete shapes. But we have a database of shapes, so we want to be able to use our database of shapes already in the program, so we don't have to build that from scratch. And when you can see here, it's actually based on the top portion here, the database AISC right now. But you can switch to any different database I have available. So you have Mexican, for example, listed there. I have Canadian shapes, and you'll see as I choose a different database, the different wide flanges change on the left side. So I'm going to go back to AISC. That's what I'm most familiar with, so I'm going to use that for my modeling here. But what I can see is I can see the wide flange. I've got tube shapes. I've got different pipes and channels, everything that's available in my RISA-3D database. I'm going to find actually right in here. So let's start building a model a little bit, and we'll build a composite section so we can actually talk a little bit farther about how the calculations are working as well. So I'm going to go and say File, New Section File. I'm not going to save this one here. I'm just going to start from scratch using this hot rolled section. And we're going to name this, before we get started, let's rename this section. It's going to be a capped wide flange. So I'll say Cap WF is my title. Say OK. And if I go to the RISA hot rolled section, I'm going to choose something. Let's see, I'm going to find this shape that we might use, how about a 16 by 31? If I just double click on that, this is my W16 by 31. And I double click on it, you can see it has the proper dimensions for that shape. So I'm listing here W16 by 31, and I have the depth, and I have the width there all defined for me. So I don't need to actually do all that stuff, but it's good to verify that. This is going to be a cap section, so what I'm going to use is a channel on the top portion. So if I click on the channel and I scroll down a little bit, I can find I'm going to use an 8 by 13.7 here channel. So it puts it right in the middle. That's not quite what I want, but I'm going to rotate that first. So to rotate, I do want to make sure I select it first. And then I can click on this rotate right. We'll actually just rotate it 90 degrees. And I see it just goes right into 90 degrees for me. If I need it, if it was flip-flopped by accident here, I could flip-flop it, but it's actually okay right now. And what I'm going to do is to move this up, I'm actually going to use my parallel align tool, that tool we saw earlier. If you just click on that, and with that selection there, I can actually just highlight the inside of that channel, and I'm going to put it right at the top of the wide flange, and they just align for me automatically. So once I have it all aligned, I can see that I've got, this property is ready to go. This is what I am calling as a capped wide flange. So on the right side, we can see a little bit farther about, we got the total width, the height, the area is a real important one, moment of inertia, all of that starting to fill in for me. And one of the things is it's asking for a maximum thickness. So we've got here is 0.44 is my maximum thickness for this shape. And what I can see here is if I double click on this wide flange, actually, it's going to show me here this is the maximum thickness it's finding is 0.44. It's actually, I might think that the maximum thickness would be maybe a combination of these two. The program's trying to do its best to calculate what the thickness is, but it looks like it's not quite getting that this channel's hitting on there. So what we've got is the ability to override that. I want to maybe make sure that I account for this section here, this thickness 0.303, as well as the 0.44. That's what I want to count as my maximum thickness, the two of those. So what I might do here is I might change this to be 0.743. It allows me, you can see that's kind of the only thing in black that's allowed to be changed. Now, it has this recalc button. And if I have that recalc button turned on, if I try to make a change to something, if I scoot things around, it's going to recalculate it for me, and it's going to do it automatically, bringing it back to 0.44. What I want to do is make sure that the program keeps what I overrode it. So I uncheck that button so it will not recalculate it for me. So it's going to use my overridden button there, or whatever I put in there. And then I can see that now the program will use this for my calculated values. So this is an arbitrary shape here still. I'm going to be using a general arbitrary. So when I bring this into RISA-3D, this is still a general shape. It won't get code check. But I want to use this as kind of how we'll see how this is different than when we use hot rolled. When we use general shapes here, what you'll see is it automatically calculates everything, but at the bottom, when we look at the torsional J calculation here, we'll notice that it says no calc. The program is asking us specifically to push the J equals button so that we compute the torsional calculation. So if I click on that, it says here it calculated that for me based on the W16 by 31. That's the J calc for that. And then it's got the channel shape, and that's the J calc for that. And then it did a summation. It just added those two pieces together, and that's the total J. So that's one approach for how the software will calculate the J calc. We actually can make that a little bit better. I'm going to scroll this a little to the left, and we'll see some of these icons. In your system, when you install RISASection on your computer, you probably have a bigger screen resolution than I do right now because we're doing a presentation. So you might just see these buttons automatically, but if you don't, you can always scroll a little bit to the right and shorten these up a little. And what we see, we have a little button in here that says Merge Shapes. So right now, these are two distinct shapes that we're having in the properties. What I can do is I can merge them, and we see that that line goes away, and they're now one whole shape. The program now considers this an entire shape, and I can do a little different type of J-calc there. If I click on the Solve button, what's happening is it's meshing. I don't know if you saw how quick that happened, but we're doing an FEA solution of meshing this into little pieces to find now the area of that and the J-calc. So it's a little bit different when you do that merge tool. And you can see now it's the J-calc went to a different number, actually. It's a 1.074, so this is a lot more accurate of your J-calc. So you're going to want to mesh those tools, mesh those sections together. If by chance you don't, it's okay. You can, or let's say you made a mistake in your model, you can unmesh them. There's a meshing button and an unmeshing button. So when you build that there, you can unmesh it. Even if you maybe this wasn't actually the shape you needed, you can unmesh it, delete it, and replace it, and then mesh it back. Merge it back together so it's meshed there. And I'm going to expand that. And so when it's meshed, let's solve it one more time there. We can see it did the J-calc for us there. So we get that J-calc torsional J there. So that's what my capped wide flange looks like. Let's build another shape. So I'm going to go back into, first before I build that shape, I have to create a new section in here. So I'm going to click on Add New Section. And this one I'm going to rename it. So I'm going to actually use the icon up here. It says Rename Current Section. You'll see in here I'm doing things right-clicking or I'm doing things with the icons. Either way. So I'm going to click on the Rename the Section. I'm going to call this one a Built Up. Built Up. I can spell, wide flange, and I'm going to say OK. And I'm going to go over to the RISA Hot Rolled database here, and I'm going to find a couple shapes. So let's pull these in. I'm going to go maybe scroll down and get myself a W12 by 79, let's say, and I'm going to go ahead and put a WT on this. So let's add maybe a WT at the bottom here. So I'm going to click on the shape here from the WTs, and I'll find a list of different WTs. I'm going to go down and put a little small one, maybe like a 4 by, and we'll scroll all the way down, and we see here about a 4 by 20. So I click on that. Okay, so not quite the orientation I want. I'm going to flip it upside down, and then I'm going to scoot it down a little bit, just dragging in just to help me. I could do this different ways, lots of different ways I can do this, but let's scoot this down, and then I'm going to use that parallel line tool. I love this tool, so I'm going to use it a lot here. I'm going to click on that line right there, and it's going to parallelly align with this section right here. Okay, so it lined itself right up to that portion or that edge, and that gets me half the way, but then it looks like it's off kilter, it's like a little off the center. So I'm going to highlight them both, and I'm going to line them up in the center here. So now I have a little T section below that. And let's build up the top flange. Maybe that top flange is going to just be another steel shape. Let's just stick a little bar, like we're actually welding a piece of bar on top of there. So when I use a solid rectangle, wow, it fills the whole screen up. No problem. Just highlight it, and you can just sort of drag it around a little bit and get it to a smaller size and kind of put it up here. And let's double click on it so we accurately get what we want on that. And I can see here, in here, I'm going to say that I want this to be like a 10-inch. So let's call it out as a 10-inch, and let's give it maybe a 0.75 thickness. So just as if we were kind of rolling this together here. And I'm going to highlight actually just this top portion, again using my parallel align tool. I'm going to select that, and I line them up. I'm going to just also make sure that they're all vertical, it's centered here so that they're all touching the same center line. So you've got all of that in place, and this is kind of my starting of my built-up wide flange. Now, as I mentioned, we were using an arbitrary general shape in our capped wide flange, but in our built-up wide flange, what I'm going to do is change it to a hot rolled section. We talked about this is a brand new feature in version 2.0, and what you can do instead of a general shape, we can use a hot rolled steel shape. So once I do that, you'll see first thing you might notice is a lot of things changed on the bottom when I flip that. So different things are being asked for because RISA-3D needs different things for code check information and the parameters that go into the code. So in the shape type here, if I click on that, you'll see I have channels, wide flange, basically every possible way that the AISC code might look at it and say, what type is this? What things should I check? So this one looks very similar to a wide flange. It is not a wide flange anymore because it's got all these different pieces on it, but it's very similar. We'll still keep it in that category. So I can't really think of another type that it might fit into. So I'm going to leave it as a wide flange, and when I come down here to the properties, I'm going to see that lots of things are calculated. Again, still I see very similar things with the width and the X-bar and the area, but now the flange thickness is a good thing to indicate. Again, the program is what they're internally doing is trying to cut a line down the center here. And the program is cutting sections, and I'm trying to sort of draw this to show you a little bit, but a section across the entire section, it draws a line. And it does this several times up and down to try to find out what is the flange thickness. So in this case, if I cut sections across here, I get the thickness of this WT flange here. I get the thickness of my actual wide flange thickness, as well as this little plate. And the program will basically count up all of that horizontal thickness it finds and divide it by 2. So it's saying half of it's going to be in the top part of the wide flange and half of it's going to be on the bottom part of the wide flange. And it comes up with this number of the flange thickness of 1.1. And that's basically a pretty safe number. It's kind of an average of what we've got. We're looking at 0.735, and we're looking up here at 0.75. So it's kind of a combination of that, and an average is probably pretty good. If I took the top two, that thickness might be a little bit higher, but the average is kind of working it out, especially as we look down the lower portion. But I can override that if I wanted to. I can uncheck this and override it if I needed to have it control over that. Same thing with the web thickness. If we had different sort of pieces of web, we might be able to control that. This is pretty obviously kind of probably, well, we can consider this as a portion of our web. Maybe we can even lower this number if we wanted to, because that is actually 0.47 from that portion there. But we see if we change that, we can change all the different pieces there. We can override the RT there, and all the calculations are done for us. With the actual hot rolled section, the torsional calc is already done for us there, so we've got that all in place. So this is what we're going to call as our hot rolled steel section, and when we bring this into RISA-3D, we'll see that this is in our wide flange family. I'm going to add a new section. I'm going to click on new section here, and I'm going to call this one cap channel. Oops, let's rename cap channel and say OK. And I'm going to put some hot rolled sections together to create a capped section, so I'm going to find the channels here, and I'm just going to find myself an 8 by 13.7 maybe. Once it's in here, I can just copy it. I can do a couple different things to copy it. I can use the copy command. I can then paste it right here, so these two icons. I could also have gone to Edit, Copy, and Paste in the drop down here, or Control C and Control V, just like you're used to in your Windows applications. You can do it that way as well. So if I click on that, one of these channels here, I'm going to rotate it. I'm going to flip it around, flip it this way actually, horizontally, and I'm going to line it up vertically. So we're going to click on that so they line up onto the top. And then I'm going to use some of my other tools here, like my stack horizontal, so they pop out, so they actually go in that direction. So that's our channel here shape. Now, if we consider our channel, it's a hot rolled section, so I'm going to change it to hot rolled steel. But it's not a wide flange. It's actually going to be probably more like a tube in behavior if we can make this act compositely. So I can click on tube, and I can scroll down, and I can see that there's a thickness to that tube, and I can see below here I've got the area, the moment of inertias, and the different pieces that go into that. This thickness is probably dead on. Maybe we'd have to worry about the thickness right here, but we might want to put something to reinforce it to make sure we get that thickness there. So we've got this all set in as a tube. The last piece I want to do, I want to add in one more. I'm going to do a back-to-back back-to-back channels. So this one I'm going to rename here. It's going to just be B to B for back-to-back channel, and say OK. And then I'm going to go into the hot rolled database, and I'm going to go to the channels, and I can go and drop in maybe a smaller section, maybe a 6 by channel here, 8 by 2. Again, I'm going to just copy this, and I'm going to paste it, and I'm going to flip it around in the other direction and just get it here. Not quite right yet, but if I highlight them both and kind of align them vertically and then align them horizontally, they match up together nicely. So I've got them all set in place here. So with all of these in my file, I'm going to say save. I'm going to save this project here. I'm going to call it the builds up sections and say save. It wants me to calculate one of my section properties. I forgot to do the back-to-back. Oops, actually, I want to change this back-to-back into a hot rolled. I forgot that one piece. So it was now a general, which would have been okay, but we really want to see how this behaves, and the wide flange is what I'm going to keep it as there. So I'm going to say save. And I'm going to close this down, and we're going to open up RISA-3D. So the key when you bring your RISASection file into RISA-3D, you do need to start a brand new session of RISA-3D. Right now with that little, you see how my mouse is thinking, what it's doing is finding all the database information. It's finding all the section properties that I just created, all of that. Now that doesn't happen when you don't open and close the model. So it is key that you open a new session of RISA-3D in here, shutting the program down completely and opening it back up. Once I'm in here, let's double check that we find what we just created. So I'm going to click on Edit the Shape Database. And when I'm in here, what you'll see is this is a RISA-3D model, just a standard brand new RISA-3D model. You have what you have called a database manufacturer. And maybe you're not used to even changing this because you use AISC all the time. But what you can do is you can choose from different countries. You can also scroll down and pick up RISASection. So if you pick up that RISASection there, what you'll find is these built-up sections I just created. You've got the back-to-back channel listed here that I just made and the built-up wide flange, and it's in the wide flange section. We also made that channel, that cap channel, and you'll find that right inside that cap channel portion. We also did one that was not in the hot rolled family, and if you go over the general tab, I don't have any general shapes in here, but I do again have the ability to drop down and find my RISASection database. And I can find my built-up sections here, and that's that capped wide flange. You can actually view it. You can't edit it here. I'm not going to change it. If I start to edit it, it would actually create a new general shape because RISASection wouldn't be knowing I was altering these values. So if I want to make modifications to this, I can. I will create a brand new one for me. So I've got all this capabilities here in RISA-3D. Let's just build a quick model and see how this works. It's just like what you did in, when you were just building a normal model in RISA-3D. You can use these new sections that I have. So I'm going to just draw new members. I'm going to click on Draw New Members, and this is just a graphical way. If you're not familiar with RISA-3D, this is a graphical way to start a model. And it's hot rolled, and I'm going to come in here and start a shape. So I'm going to use those cap channels as my columns. So I'll come in here. Again, you'll see the same database type of thing, but I'm going to scroll down to RISASection. And I want to use those tubes, those cap channels. Those are what I'm going to use as my column. So I'm going to say OK. And you'll see cap channels popped in there for me. I'm going to call these maybe A992. I'm going to use them as columns. And I can just say Apply and sort of draw them on my grid. Okay, so you can see I just click on the grid section here, and I can just, let's do a 12 by 12 portion here. So I'm just drawing that as we go. The next one I'm going to just do is I'm going to draw new members one more time. And I'm going to build a frame here. So the next piece I'm going to do is going to click on the, actually we are in the tube section. I'm going to go to the wide flange section now. And I want to do maybe that back-to-back channel that we created. And I may put that in there as a beam section. So I'm going to say OK and change that to be a beam. Okay, the rest of the material is fine, the A992. It's a wide flange there, so I'm going to say Apply. And I'm just going to kind of click across there and create myself a beam there. The last piece I want to do is this top portion. I'm going to do that slightly different. I'm going to use that general shape that we had created. So I'm going to click on the General tab. I'm going to click on this here, and I see under, again, it's blank, but if I click on RISASection, I'll find some of my built-up sections, so my cap wide flange. Say OK. And you'll see your capped wide flanges right there. And I can say Apply and draw directly across there. I'm going to just put some loads on this, so I'm just going to put a boundary condition on the base of this frame. And I'm just going to put a little load on it just so we see something happening in our model. Push Apply, and I'm going to load up some of those beams there. And we see here I've just put 1 kit per foot running on each beam. And I'm going to create a load combination. So I'm going to say this is total load, and I'm just going to give myself, if I put a Y in here with a -1, that counts for my self-weight. It's a quick shortcut to do that if you haven't seen that before. And I'm going to put a 1 in the BLCs with a factor of 1, and I'm just going to solve this model. So when it's solved, I'm going to make sure here to go, and I'm going to turn off my load so we don't get distracted by that, and I'm going to turn off my grid. What we've got here, and let's just confirm what we used. If I click on this, this little icon, I can choose the shape that we're looking at. So we can confirm I did the cap channels on the sides, I did that capped wide flange, and that back-to-back channel. So let's get code check. That's what the new piece in here is that we get to see code check. So design results, oops, I forgot P-delta analysis. So let's turn on P-delta and say solve current. So let's solve for the P-delta analysis. And with P-delta turned on, okay, then I get to see the code check information that we have listed in here. So these cap channels are getting run with code check, and then I can see the back-to-back channels are with code check. The cap wide flange is not there. It doesn't get code check, okay, because that was a general shape. We left that one as a general. If we click on the detail report, we can find out a little bit more information based on that too. So I can click on there, and I can see the detail report of this cap channel. It shows me the axial forces, the shear in the moment, and then below all this information gives me what was the code information. So the maximum bending check, all the allowables that went into play here, and we got to see the different pieces of shear check as well, and we can see all that information. If I click on the back-to-back channel, I get the same information. I get my axial forces and my shear in moment. I get below here, I get to see all the information that went into that code check and the equation that governed. If I close that out, I'm going to click on the capped wide flange, and what are we going to see? We're going to see general information. So we get very similar information. I get my axial, moment, and shear, but I didn't tell it what kind of code should be run on that one. So I don't get it. That one's going to get just as a general shape. So you basically get everything you have on the rest of the model, just that last piece is out there. Each one of those members has member forces. You get all the different pieces of information in the results there that you might see, or just seeing it basically in this format here. So I'm going to jump back into RISASection for a second. Let's see here. I think I closed RISASection in the background. But if I open it back up, I want to show you one more thing before we jump forward. So if we look at, we were doing that built up sections. And one last piece I wanted to do in here is I want to talk about the reporting. So we can do, once we've got our model all set to go, we can look at some of the reports. And I'm going to click on, oops, I'm going to print them. I can look at the results here, and I can look at the report creation wizard. So if I click on that, this basically shows us a little bit more about how we can look at the reports in RISASection. It's a great tool, and I can turn on all the different pieces in the main report as well as the pieces in the different sections, and it'll show me a report. I'm going to say Generate Report. And you should see here now, I'm going to zoom in a little bit closer so we can see. This is this capped wide flange that we did, and it gives us all the basic properties as well as the calculated properties for this model. And we can zoom out a little bit. And we can show here kind of basically each shape has this ability, and we can print it out. We can see different pieces in this. And this is a great tool for when you're reviewing your results in here. So let me jump back here, and I'm going to show you. Let's see. So then the second item on these features for the new version of 2.0 is really going to be the DXF import. So I want to talk a little bit about some of the rules that we have for DXF import. If I click on here, starting out, any DXF format, any CAD format can be saved into DXF. So I'm going to be using AutoCAD, but if you have any other different types of software, all you need to do is just make sure that you can save as a DXF. It's coming in as 2D shapes only. So what we've been looking at is section properties, and we can only see that as in a two-dimensional. So you're going to want to draw that in as two-dimensional or save it as two-dimensional there. If you have a three-dimensional model, you're going to want to make sure you collapse it into somehow into a two-dimensional only model. You can use lines or polylines. So we'll see in the models I've made here, there's some complex shapes I've built with both lines and polylines. You can use, you need to use lines to define the inside edge and the outside edge. So when I look at this picture up here, this is my representation, my very rough representation of a tube. And what you see is that I define that tube with an outside edge in yellow and an inside edge in red. You don't need to use colors. This is just to help you see this. And what it is it's showing you I actually have to draw the thickness as in two lines. So unless it's solid, if I wanted a solid rectangular section, I would just remove that inside edge, and then it would be a full solid. The next piece is you need to have closed sections, or closed shapes. So you'll see here below here, you can see that I have a bad shape below here because it's got an open edge. And the program can't decipher what I'm trying to figure out here. But this U shape is allowed as long as you close off that top two sections there. So you can see it just needs to be a closed portion. I'm going to start by showing you some of the AutoCAD shapes I brought in. Let's bring in AutoCAD. If I can drag it over here, you can start to see. Let me size my window a little bit better. Sorry, this is a tight window for my AutoCAD, but we'll start to see that. So this shape is something I built in AutoCAD. It's just it's similar to what a user had requested from us, and I kind of just free-handedly drew. I don't know. I think it's more of like an extrusion of some sort. But you'll notice it is closed shapes. I did the thickness for everything as a closed shape, and I can import this directly into RISASection. These are just lines how I built this. The edges and the corners there are fillets, so I could close things off in these corners. And again, these little sawtooths are just lines. But you could use polylines, right, as well too. I was more familiar with drawing it with lines. So in RISASection, I'm going to go ahead and open up the file. I'm going to open a new file, and so I'm going to import it. So to import inside of RISASection, that title, let me jump back to AutoCAD and make sure you see that. This is, I'm going to say save as, and that's how you save in here, save as, and it's going to pop up a window, and it's going to just say save as a DXF. And you can save as any type. I'm using 2010, but older versions will work. And it's going to, right now it's a DXF. It's an extrusion, I called it extrusion 1. And I can just save that. It's already there. I can just say replace it. And I'm going to jump back here to RISASection. So inside of RISASection, the way you import that section is just to say File, Import. And I can click right on RISASection, and I'm going to just find that section. I placed it right in my RISA folder, but you don't need to. You can put it anywhere as long as you can navigate to it. And that was my extrusion 1. Say Open. It asked me some questions. So what units do I want to do this in? And I'm doing everything in inches right now. What is my CAD plane? A lot of folks change their CAD plane not to be their XY, but mine was my XY and my vertical was my Y. So I can adjust that there, and I can say OK, and I see it pops right in there. So the model, it's coming in with all those different pieces. It comes directly into RISASection. It's all calculated basically on the right side here. We get all the calculations, and you can see that that complex geometry comes right across. I'm going to bring another one across. Let's see here. The next one I want to bring across, let's talk about this one a little bit. So this is RISA. This one is 2 types of extrusions. I sort of came up with this, and then what I wanted to talk about this one is, one thing as you can see, I have a couple different layers on this one. So if we look at, I'm just going to highlight this, the yellow portion of my AutoCAD drawing has an inside radius, and the other portion is just my default 0 layer. And these are different layers. And layers will come across, they sometimes can be helpful, and we'll see how they come across a little differently if you define layers. And this one here just is a single drawing with no layers. So first thing we'll do, we'll go back to RISASection and import them. And the other piece I wanted to show you is that those both can come across at the same time, even if they're in the same file. 2 sections at the same, 3, 4, any number of sections can come across in the same file. You may not want to do it that way once you get it in, but we'll see that in a second. So I can do extrusion 2. That was the second one we just looked at. Import it. It has the same information. I'm going to say OK. And I can see things come right across here in RISASection. So I have the ability to see that the way they came in is slightly different than the one versus the other. So what we see in here is that we've got this kind of black solid that's happening inside there. I can actually click on it, and you can see the outline of what happened in there. The layer itself is kind of bringing it in because it's its own layer, so it gets a solid outline and doesn't have an interior. So when I said it has to have 2 lines, an inside and an out, well, that layer is just an outside layer, so it doesn't know that it's an inside of this portion. So it's a different approach. One of the nice ways to do this is that I can use things to tell the program that this is actually a void inside of there. And so when I use the same layer, it knows that it's in the inside. This one, I can actually just click on that portion, and if I click on, actually I'm going to click on this little tool up here which says Edit Shape Layout. And this portion right here, we have this multiplier, and that multiplier was there to help us adjust the relative weight of the shape, but it also will help us define it as a void. So I can tell it it's a -1 multiplier in there, and I can say this is a -1 multiplier right there too. So these inside sections are now -1, which means that they actually are empty or voids. And we can see, I'm going to actually copy this or cut this one out. Let's see if I can grab it well. I'm going to grab this one, and I'm going to cut it right out of this section. So this one lives on its own, and I'm going to go up to RISASection, the section 1. I'm going to paste it right in there. And then we can see in here that this one is placed in there by itself. I'm going to go back up to this one here. And let's just verify that the areas worked out well, because then we can verify that my void tool worked. So right now I'm getting an area of 1.053 for this section, for this entire section. And if I go over to this one where it recognized that it was 2 different pieces there, I also get an area of 1.053. So it's just 2 different approaches to get the same thing in here. The next one I'm going to import here, I'm going to grab this here. I'm going to show you some things that are maybe not allowed, and we'll see how we can fix them. So if I'm going to go to this one called Not Allowed, and what we can see in here is that this is just a single line, and this one's not going to be allowed. The program's not going to understand what to do with a single line. And same thing as, like we said, a U shape is not going to come across unless it's a closed shape. So we need to actually have thickness to this. And this one here is a solid. It'll come across as solid. So let's just see how the program alerts us to that. So I'm going to say File, Import DXF File, and I'm going to scroll down a little bit here, and I'm going to open up, let's see, that was the Not Allowed, and say Open. and same message comes up here. But what does come across, it says some DXF shapes were not imported because their outlines were invalid. I can say okay, and this one, only that solid came across. And it was because those other pieces weren't allowed. So we can fix that. It's really pretty easy to fix. I'm going to come in here, and maybe what I intended was this to have a 0.1 thickness. So I'm going to say maybe offset this by 0.1, and I'm just going to sort of shoot this offset to by 0.1. I'm going to close it off with some lines, and I'm just using some of my snaps to close this off there. Same thing with this U shape. I'm going to offset this by 0.1. So I give it a thickness of 0.1. And so let's see. Offset is one of my favorite tools in AutoCAD. And I'm going to fillet this. So I'm going to just do a fillet closure on this guy. And I'm going to do a fillet on this side. And then I'm going to just draw some lines to connect the top portion there, because it still wouldn't have gone across. Oops. It still wouldn't have gone across had I not closed it off. And I overshot it. Sorry, we're running out a little low on time, but I want to make sure I can show you some of these different pieces here. And so I've got this in place, my closed U shape, and then my big opening here. I want to make this more of a pipe, so I'm going to offset this, and I give it a thickness. So now these are closed shapes, and now these are going to be okay. So what we're going to do is just going to say Save As, and I'm going to tell the program to save it as an AutoCAD DXF, Save. It says, you want to replace it? I'm going to replace it with this new shape that I built, Better Shapes. And I'm going to go back into RISASection. I'm going to just delete this one because it wasn't a good one. So I can just say remove this section. And then I'm going to say File, Import one more time. I'm going to go into the Not Allowed one that we just saved. And I'm going to say OK and bring it right in. And now you get to see that those came across just fine. So I've got all sorts of different pieces in here. I'm going to go bring one more in. I'm going to go to Import DXF, and I'm just going to show you one more one that my great artwork I did here. Import and say OK, and actually I think it's, yep, and it's got kind of a keyed function here, a little strange extrusion. I don't know what you'd be doing with this kind of shape, but at least it kind of gives you an idea of some different types of things you can bring across. So we've got a lot of different capabilities with this will go right over to RISA-3D just like our other pieces did. If we say this, and let me shut this down here, and I'm going to shut this down here, and I'm going to bring it right inside. If we go into RISA-3D here, we can see that in the databases, I'm going to clear this out for a second here. What we can get in this general here, RISASection, is this DXF webinar one that I just created here with all the different extrusions and the not allowed one right inside of here as well. So you can just build your model directly from that as well. The other piece I want to show you too is the rendering. So when you identify that the model actually was based on a wide flange or a tube shape, it's just going to build it just like it would have normally in a gray type of rendered view. Now this top one was, what we said was, I'm going to double click that and read it here, a capped wide flange. And the way the program is going to do it is it's actually going to render this really nicely. It's what we're seeing with this capped wide flange is we see a shorter green horizontal line and a vertical line there showing me the depth. So this helps me orient it. If I didn't recognize here actually that this maybe needed to be on its 90 degrees, and you'll see it rotates it. So it's actually weak axis is in bending rather than its strong axis. So you can kind of modify these things, and what's really nice when it comes into RISASection, you have an idea of what you're looking at in RISA-3D rather than just a sort of a blob, which wouldn't be very helpful, especially if you don't know your orientation on the member. So it's a great way to see these arbitrary shapes. The hot rolled shapes will come in just like they always have seen, tubes or wide flange, things like that. So as we go forward here, I just want to talk about some of the additional resources you have. The RISASection help file is a great tool. We spend a lot of time developing that and working on making sure that that's up to date with all the changes we make and helps you walk you through the different things. RISASection reference manual will be identical to the help file. You can always email support at risa.com. You've got that option to ask us more questions. RISA News is another option opportunity to see exactly, we have a website called RISA News, and you'll see that as soon as you finish the webinar here. And we post lots of different articles about how to use things, what's new in the software, what's going on in a company, and things like that. So it's a great resource there. If you have any additional questions about the software RISAsection, let us know. We'll be on for a couple more minutes here, and but you also can always take a look at our Q&A, as Amber had mentioned earlier. And if you have any more questions, info@risa.com is a great, just email us directly. Thank you so much for your attention today.